You see the headlines, but the real story in AI progress isn't in the scores. It's in the methodology of the tests. To truly understand a model's capabilities, you have to understand what is actually being measured. The benchmarks are not all the same. Each is a specialized instrument designed to probe a specific facet of intelligence. Let's dissect 10 of the most significant evaluation suites professionally. We begin with two benchmarks that test coding, but in fundamentally different ways: Live Code Bench and SWE-bench. First, Live Code Bench. This benchmark emulates the world of competitive programming, like Elite Code or Top Coder Contest. It tests an AI's ability to write correct and efficient algorithms for self-contained problems from scratch. The AI is given a problem description like find the shortest path in a weighted graph, and it must generate code that passes a set of hidden test cases under strict time and memory limits. This is a measure of pure algorithmic skill and optimization. By contrast, SWE-bench, the software engineering benchmark, tests real-world software maintenance. It doesn't use toy problems. It pulls actual bug reports from major open-source GitHub repositories like Django and NumPy. The AI is given access to the entire messy, complex codebase and the user's bug report. Its task is to generate a Git patch file that resolves the specific issue. So while Live Code Bench tests creating a perfect small algorithm, SWE-bench tests the far more common engineering task of understanding, navigating, and modifying large existing human-written systems. Next, we have three distinct benchmarks for mathematical reasoning: Math, Amy, and HMMT. The Math benchmark is a test of breadth. It's a massive dataset of 12,500 problems covering the standard U.S. high school curriculum: pre-algebra, algebra, geometry, trigonometry, and pre-calculus. The problems are written in LaTeX, requiring the model to parse complex mathematical notation before even attempting a solution. It's designed to measure the robustness of a model's foundational mathematical knowledge across a wide range of standard topics. Amy and HMMT test mathematical depth and ingenuity. These are not curriculum tests. These are prestigious competitions for gifted students. The American Invitational Mathematics Examination, or AMY, features 15 complex problems where the answer is an integer from 0 to 999. The problems require clever, non-obvious insights and creative problem-solving strategies. The Harvard Munn Mathematics Tournament, or HMMT, is similar in spirit, but is a team-based event with even more difficult problems. These benchmarks don't measure if a model knows math. They measure if it can reason like a true mathematician when faced with a novel challenge. Now let's examine two benchmarks for agentic capability and instruction following: Terminal Bench and IFL. Terminal Bench is a leading benchmark for evaluating AI agents. An agent is an AI that can take actions to achieve a goal. Here, the AI is given a goal in natural language and access to a realistic Linux command line terminal. A task might be find all .log files in the home directory that were modified in the last 24 hours, create a compressed archive of them, and report the archive's SHA-256 hash. This requires long-term planning, chaining dozens of commands, find, tar, SHA-256 sum, and understanding the output of one command to inform the next. It's a direct measure of practical tool-using autonomy. IFL, on the other hand, isolates the specific skill of instructional fidelity. It's less about achieving a complex goal and more about strictly adhering to complex constraints. It consists of about 500 prompts with explicit positive and negative rules. For example, write a summary of the provided article, but do not use any words containing the letter A, and ensure the summary is exactly 4 sentences long. This tests a core aspect of AI safety and alignment. Can the model be precisely controlled, or does it ignore parts of its instructions? It's a measure of reliability, not capability. Finally, 3 benchmarks that probe different dimensions of knowledge and reasoning: Zebra Logic, GPQA, and MMLU. Zebra Logic measures pure symbolic logical deduction. It uses constraint satisfaction puzzles like the famous zebra puzzle, where a set of premises must be used to deduce a conclusion. The key here is that the problems are self-contained and require no external knowledge. This isolates the model's working memory and its ability to perform formal logical inference, a critical skill for tasks in verification, validation, and planning. GPQA, or Graduate-Level Google-Proof Q&A, tests deep, expert-level reasoning. Its questions were written by PhD-level experts in physics, chemistry, and biology, and were specifically designed to be unanswerable by simply searching the web. Answering a GPQA question requires synthesizing information from multiple scientific principles and applying them to a novel scenario. It's a direct probe of a model's ability to reason from first principles rather than just retrieving stored facts. Lastly, MMLU, the Massive Multitask Language Understanding Benchmark, is the ultimate test of broad, crystallized knowledge. It comprises tens of thousands of multiple choice questions from 57 different subjects, including questions from official U.S. professional and academic exams like the bar exam, medical school entrance exams, and more. A high score on MMLU indicates that a model has successfully absorbed and can accurately recall and apply knowledge from a vast and diverse range of human academic and professional domains. It's the most comprehensive measure of a model's book smarts. In conclusion, these benchmarks are not interchangeable. A high score in live code bench doesn't imply skill in SWE-bench. Mastery of math doesn't guarantee the ingenuity required for AIM. Each test provides a crucial, distinct signal. Understanding these differences is the first step to moving beyond the marketing hype and into a professional analysis of AI's true capabilities.
Thanks for watching this. If you like it, subscribe to our channel. Madrase is a new way to learn technology.